Patroklos, I think that in 4 minutes we can start.
4 minutes, okay, great.
Okay, I think that we can start.
Okay,
If people is
great.
join us. Okay.
Okay, great. So can you hear me fine?
Yes.
Yeah, okay, great. I'm going to switch to my screen. Okay. you see the slides right now?
Yes.
Okay, great. First of all, I would like to thank Edu for the invitation. It's my pleasure to share my knowledge about SonarQube and clean code quality. Before I start, let me briefly introduce myself. My name is Patroklos. I am from Greece, and my short history with SonarQube is the following. I started working with the tool 5 years ago at the end of 2009. Very quickly, I became an active member of the user and developer mailing list. I contributed to several open source plugins, and 1 year ago, I managed to be one of the authors of the SonarQube in Action book, which was published by Manning. So all this history somehow, make me like some experienced guy with SonarQube. So I'm going to discuss a little bit about how SonarQube can help us tracking down technical debt and manage the code quality. And I'm going to tell you some things about the continuous inspection paradigm and how we can easily achieve it using SonarQube. So this is the agenda that we're going to have today. It's really easy, so I'm going to pass it right away. So my first slide is this one, and when I try to start using a new tool and try to learn new things, the first thing I want to know is to define some basic concepts. So one of the first things that I wanted to learn is what is actually the meaning of code quality. So I tried to find on the internet some definitions that might be very helpful or convenient. The truth is that I didn't find any definition about code quality. On the contrary, I found several ones about software quality in general. So the only nice picture I saw was this one that you currently see, and I assume that you have already seen it. So one could say that code quality could be how many times a code reviewer, when reviewing a code from another colleague, says the word "what the fuck." That's quite funny, I guess, but it's a nice one to use, especially if you are willing to have fun with your colleagues. But I have, of course, to come out with a more sophisticated and more serious definition of code quality. So for me, quality in the source code, it's an indicator about how quickly developers can add business value to a software system. And to make it more clear, if you find yourself as a developer or the team of the developers actually is not doing any new features, is not implementing any of the requirements of a customer, and they are just fixing some bugs or trying to refactor the code, then something must be wrong with the quality of the system. So if developers can easily add new business value, then quality is on the top of that. So the next thing that I want you to share about is why we need to measure code quality. And the first thing that I learned is that source code is the heart of every system. It doesn't matter if you are doing, if you are agile, if you are doing Scrum or XP, Lean, Kanban, or whatever, or if you are still using waterfall. There is only one same thing in every process, in every software, in every development activity, the source code. So as we try to keep our body in a good shape, to be fitness, to be healthy, it's exactly the same with the source code. So one of the most important things is that the source code should be at the highest shape, at the highest quality that we need in our software. So the next one, which is quite contradictory, and some of you might not agree with me, is that we, the developers, Actually, we are not writing new software, but we most of the time we are maintaining legacy systems. Let me clarify this and explain it in more details. When I ask developers in conferences and workshops to answer the question, how many of you are writing are working on a project but it's less than 3 months old, actually I don't have any replies. So most of us were working on projects and products that have more than 3 to 4 months life cycle already. For me, any software that has at least one customer, that has at least one live instance, live installation, it's a legacy system. And this is because as soon as as soon as one customer uses the system, we need to take care of the existing features. Everything new that we are going to add has to be compatible with the existing version. We should not break anything. We should keep the existing feature and existing functionality as it is without breaking and without causing any problems to the existing customers. So this is really important, and for that reason the quality of the code should be maintained at the same level as it was in the first release of our system. And the next thing that I really have to share with you is that we the developers are usually really lazy people. We want to do as much as possible with the lowest time to spend. We tend to copy and paste code, to find ready code on GitHub or everything in the internet. We tend to take external libraries to do our jobs. We don't want to write much code, and we want to achieve the maximum of our productivity. So this laziness is one of the basic reasons that creates poor quality in our code. So we need to measure it and find any quality flows as soon as possible and be able to fix it. So the last thing that I want to share is about the broken window theory. I don't know if you are aware about the theory. This was introduced back to the 1980s from some social scientists, and they wanted to explain to the police how they should be proactive instead of act like the fire department. So the basic idea of the theory is that if there's a building with some broken windows and no one actually cares to fix them, it is much probable that some people are going to break some more windows. And if again nobody cares to fix them, it is very possible that some vandals or bandits will break the door and sit down and intrude in this building, maybe light some fires if nobody lives in that building, and stay on this one. So the idea is that if nobody cares about something, the things are going to be worse even more. So in software and source code, it's exactly the same. I assume that all of you have been in the position where you were asked to maintain a very large class, a very large source code file, and the only thing that you want to do is just place a method right there, don't bother about the existing code, and leave it and go on to the next task. So this is exactly the broken window theory. If we don't break this cycle of poor quality, then sometime in the future this will get back to us and create problems about adding new features and maintaining the code. So now that we are aware about how important is code quality, and we know basic definition, many people ask me, okay, so what's the perfect measure? What should I measure for my project? And many people try to measure abstract numbers. For instance, I asked the team once, "What's your favorite metric that you already measure?" And they told me that they measure the number of duplicated lines. For instance, they have 1,000 duplicated lines. Hearing this number is for me extremely useless because it is 1,000 duplicated lines out of what? Out of 2,000 lines or out of 1 million of lines? So it's the same for all metrics. Almost all metrics, if you use just abstract numbers, they are useless. So my suggestion is to first of all try to use a density, meaning that you measure the percentage of a metric out of the total number of the metric. And the second one, which is more important, is to metric the evolution of this measure through time. So you need to know where is your starting point, how well or how bad you are doing for some period of time, and act on that, take some actions, and evaluate how is your improvement or how is your deterioration of the project. So to sum up, no abstract numbers, percentage is the best one, the best case, and evolution through time about metrics. And the second question is, okay, which metrics? I mean, there are hundreds of metrics around there that you can measure, so which one is the best? And here, I would like to introduce you the 7 axes of quality. These are some terms that are introduced by SonarQube and SonarSource. Of course, I'm not speaking about this kind of axis, or not this one, I guess, okay? I'm speaking about the 7 deadly sins. Let me briefly describe them to you. We have design, complexity, documentation, potential bugs, testing, coding rules, and duplications. Provides metrics and specific numbers for all 7 axes of quality. I'm going to show you in details right away. And moreover, there's a formula that accumulates all these metrics, all these numbers, and provides a single number, a number about technical debt. Technical debt is a metric, a buzzword, which is very popular, especially the last couple of years. And the reason why it's very popular, it is because it is easily understandable by non-technical people. You can express the quality by just a single number, which is the technical debt. And this single number can be anything. Can be working days, can be currency, dollars, euros, or whatever, or it can be just a number. So non-technical people who don't care about this technical stuff, about unit tests, complexities, and other stuff about, or which is really technical, they can see a single number and they can understand by monitoring its progress if the quality of the system is going better or is going worse.
Patroklos, excuse
yes?
me. Are you presenting the slides? We cannot see if the slides are moving or not. We are seeing the
really?
small one.
Really?
Yes.
Oh, right. I've shown several.
Just...
I've shown. Okay. Let me check again.
Sorry.
Okay. Just a second.
Okay.
So, can you see slides right now moving?
We are seeing the 7 axes of quality, but the small ones.
Nothing moving right now?
No.
That's really bad. I mean,
I think that we can work with the small ones. Doesn't matter.
so you don't see any slides moving right around your screens?
No.
Okay. So I will do the following. I will, from time to time, I'm going to share my screen from the scratch. Okay, so you can see it and understand what I'm talking about. So, okay. I'm going to continue. Can you see right now this picture?
Yes.
Okay.
Yes, this is called.
Let me explain. Yeah. Let me explain a little bit about the technical debt, and I like a nice analogy between the kitchen and technical debt. I don't know how many of you do you like to cook, but let me give you an example. Let's say that it's Friday night, and you have invited some friends in your home, and you prepare a dinner. But because you want to hang out with them, you don't have enough time to clean up the kitchen. So you leave the dishes, you leave anything that you have used on the kitchen, and you go. You still go with your friends. Next morning, you want to prepare some breakfast. You move some plates from the kitchen, and you prepare again the breakfast, but you don't have the time to clean the kitchen. If you try to do the same thing several days, apparently you will end up with something like this. And if you can imagine the same thing in the source code, let's say that you start building on a new feature on Monday morning. You copy some code from another place that you know that it's working. You do some experimental code. You write some debugging lines. You finish the code, but you forget to clean it up. You forget to remove any duplications. You forget to refactor it to make it more readable. You forget to remove any commenting or any debugging information that you have added. So if you continuously doing this stuff, if you're committing code without cleaning up before, without refactoring, then it's probably that you will end up with something like this in your source code. Okay, in the source code, which is something like this in the kitchen. So now we have defined so far some problems that we are dealing with with code quality. So the next part of this presentation is going to be about SonarQube. Let me give you some insights about SonarQube. It's a free and open source platform, meaning that you can download it and install it locally without having to pay anything. It provides moment-in-time quality snapshots. It analyzes source code and binary code and stores this data in the database. And you can see all this information using a web UI, a web interface, a web dashboards. Obviously, it tracks all the 7 deadly sins we discussed so far, and the technical debt. And furthermore, it gives you some trends of leading and lagging indicators. So by viewing a single dashboard, not only you know the current status, but you can see how well or bad have you performed from the past, and what is going to happen to your code, to the quality of your code, if you will keep doing the same thing. So you can have some indicators about the past and the future. Now, let me reshare the screen. I have to do that so you can see the latest one every time. So let me briefly explain how SonarQube works. Like I said, we need to feed SonarQube with source code and binary code, and it analyzes it using several either external or internal implementations. It can analyze the code with check style, PMD, or anything external, but it has also an internal very good analyzer. You can run an analysis using several different methods. You can use Maven, Ant, Gradle, or you can use a build agnostic tool which is called Sonar Runner. Like I said, it computes hundreds of different metrics of all the 7 deadly sins we discussed, and these metrics are stored in database. So instead of sending the results for developers like we are doing in traditional analysis from find bugs or PMD, which produce just a static HTML report, you can send developers to the dashboard. So everyone can see the same data of a unified dashboard. Things are even better because there's an integration with the most popular IDEs especially with Eclipse and IntelliJ IDEA. So developers can install this plugin and can have the same functionality without in their ID without having to move between different screens. So they can analyze their code before they commit to the repository, and they can fix any problematic parts or any quality flows before everyone can see their code, which is really cool. So again, now, before I move on to show you some of the basic features of SonarQube, let me give you some insights about the continuous inspection paradigm. This is a definition that the guys from SonarSource, which are the people behind SonarQube, have come with. So I will going to read it aloud. It is a holistic, fully realized process designed to make code quality an integral part of a software development lifecycle. To make it even more clear, this means that that if you follow this process, you are committing yourself to manage, track, and improve code quality continuously and make it as a very well integrated part of your development lifecycle. This means that it's going to be inside in your everyday tasks, just like you are committing code, you are checking out code, you're writing unit tests, it's going to be part of your development lifecycle. And like I said before, it doesn't matter which process do you use or how much customized is your own development process. Continuous inspection can be applied to anything. Now, before I show you some of the core features of SonarQube, let's briefly present some of the core, let's say, rules that apply to the continuous inspection paradigm. So everyone should have access to quality data. And when I say everyone, I mean all team members, developers, testers, architects, UX designers, team leaders, you name it. Anyone that participates in a team should have access to quality data. And not only that, everyone should care about quality. I mean, if a tester finds out that there is very little testing in a particular part of the system, should be report that to the team so they can learn about that. So everyone should care about quality, but only developers are responsible for keeping this quality on the highest level. So only developers must act to improve quality. The quality requirements should be objective and common to all team members, meaning that they all should agree on the same requirements, the same quality requirements should be fit to the development process, and all should be using the same quality rules, the same quality requirements. The metrics also should be computed on the latest code base. I mean, it's quite not very useful to see a dashboard with metrics of a source code, but it was changed during the last 2 months. It's quite obsolete and produce no value to the team. The next one is that quality issues should be found as soon as possible. So, meaning that as soon as a new analysis is running, the development team should be alerted about any new quality flows that exist in the system. These quality issues also should have a fixed timeline. The team or the developers can categorize these fixes depending on their priority and decide if they're going to fix it immediately or during the current iteration or during the current release or the next release or whatever. But every quality issue should have a specific fixed timeline. And finally, the quality data should be comparable. We should be able to compare ourselves, we should be able to compare the current situation, the current status of the project with a previous version of the same project. This is very important because you can understand the evolution thing that I was talking some minutes before. It is very important because like this we can understand how well or bad we are doing. So now let's shift to the SonarQube environment, and I'm going to show you some of the core features. Let me see if you can see my screen. I hope you can see my screen.
Okay, Patroklos, I think that you are sharing only the slides. I think you can share all your screen and in order to...
Let me see just a second. Okay. So I'm going to share again. Okay, can you see SonarQube dashboard right now?
Yeah. Yes, I can.
Okay, great. So can you see it moving at least?
Yes. Yes.
Okay, great. It's much better from the slide. Okay, so this is the one of the basic screens that you are going to see with SonarQube. SonarQube has two kinds of dashboards. There are some global dashboards that you can aggregate information of several projects, and you can have project dashboards that display information about a specific project. Both dashboards are fully customizable, and you can create your own display, your own information, depending on your demands, on your needs, on the projects you are working, or on the metrics that you care about. So what you are viewing here, it's a global dashboard that I have created for the purpose of this presentation, and you can see that I present the same projects with some different views. That's the list with some metrics. There's some projects with some lines about technical debt. This is the tree view panel, and another one which is really cool to see which project has the most technical debt for its under control. So let's move to a specific project and see how it looks like its dashboard. Now, as you can see, in the dashboard, we have plenty of widgets, different areas in the dashboard that report metrics about the 7 axes of quality we just discussed. So in the current dashboard, you can see information about the technical debt. This widget is called the pyramid of technical debt. You can see information about the issues and the potential bugs. This is about the coding rules that were defined. Then on the right, we have the widget about testing, coverage, and succession of the tests. Then it's documentation, duplications, and on the other side, we have about complexity and architecture. So we have on a single dashboard information about all the 7 axes of quality. So that's only the beginning. I mean, okay, we can see the numbers, we can see how well or bad are the numbers and how the projects are doing, but it's only the top of the iceberg. I mean, it's okay to see these numbers, but we need to drill down to more specific values. So every widget, every number, as you can see on this dashboard, is clickable. You can click on that and start getting more detailed information. So let's, for example, click on this issues number, and we are directed to a page which is called the drill down view. This is the same page that you can see when you click on any number, on any metric on the dashboard. This drill down view displays detailed information about the exact point of the issue that we are looking at. So for instance, let's take this one, the first one. You can see that clicking on that, the lower panels are filtered out, so we can see only the packages and the class that is found with this issue type. So click on a class, and then we can see the exact place of the problematic area. As you can see, the problem here is on line 94. Now, what we are viewing right now, this place, it's called the source code viewer. It is the more detailed piece of information found in SonarQube, and you can see everything about the metrics that has to do with this specific class. Apparently, by default, the source code viewer is enabling the metric that we have clicked so far. So by default, it enables the issues because this was our starting point. But as you can see on this header, there are several different other metrics. So clicking on the coverage, you can see the coverage of this class, and so on. Now let me get back to the initial dashboard and click on another one to see how how the source code viewer is different depending on the metric. Now we are seeing the coverage of these classes. What's really cool is that classes that have 100% of coverage are not shown here. So if you don't see any class here, this is good. Meaning it means that you have covered the class by 100% by unit tests. So let's click on a class but it's not fully covered by tests. So you can see that we have a slightly different presentation of the source code viewer. You can see that we have some green and red signs here on the left of the viewer. This means that this line is executed by test and the red ones are not executed by test. In some lines also, you can see that there are some numbers and we have some, let's say, orange indicators. These numbers mean that we have, in this line, we have 2 branches and none of them it is covered. Or for instance, in this one we have 7 different branches, but only 2 of them, this one and this one, are covered by unit tests. So you can dive in any class and find exactly which part of the code is not covered by unit tests, so we can act accordingly and start writing your own tests. Now, I want to show you something. The same applies to any different metric you want to see. Another one is very important. It's duplications. If you can see this viewer, you can see that it has a different layout, and it reports on the duplicate lines that can be found in specific class. And what's really amazing in SonarQube is that you can enable a specific feature which is called cross-project duplications, and it can detect duplications across all projects on the same SonarQube instance. This is really cool because you can find not only duplication in the same project, but duplications along all the projects of the same company that you are writing software for. So let's go back to the dashboard. Now, so far we've seen that these numbers are telling us what is happening right now on our project. I told you that one of the key points of continuous inspection is that you have to compare yourself with the past. So SonarQube has what we call the differential views. Here you can see a drop-down list box that you can select how these numbers have changed with some previous analysis. These selections, these options, are completely customizable. You can add up to 5 different options for each project you have in SonarQube. So for this project, let's compare it with over the previous 30 days. Now you can see that several things have happened on the dashboard. All the metrics now have 2 numbers. The initial one and the second one that shows the difference between today and the period, the delta between today and the period that we have selected. So you can really easily see which numbers are going up or down, and if your project is going good or worse. This is even useful for legacy projects, because for legacy projects, usually you start measuring the quality from a specific date, and you don't care about the previous code because it's legacy and you don't want to maintain it, you don't want to improve the quality. So it's really useful that you can see exactly how well the code and what are the new problems introduced in the system from a specific date. And this differential view is also available in the source code viewer. So we can select any date here that we have defined, and we can see only the new issues that was introduced from the delta period. Right. So the next one I wanted to show is what we call in SonarQube quality gates. The quality gates is quite a new feature introduced in SonarQube lately, and it's used to describe some thresholds that a project should pass in order to be, let's say, it has a very good level of quality. So you can define any different condition that you want. You can define conditions that are specific to the absolute value of a number, or you can define conditions that compare a metric with the previous version. So this quality gate ensures that the project will never have a blocker issue, will never have critical issues, and the code coverage on new code is always more than 80%, and of course some other conditions. Now, what's really amazing is that you can instruct SonarQube to send you an alert every time that at least one condition is broken. And it's even better that you can integrate SonarQube with Jenkins and using a specific plugin which is called the build breaker, and you can instruct Jenkins to fail the build if at least one condition of the quality gate is not met. So as you can see, you can do a lot of things with SonarQube. You can have insights about the upper level of the project, but of course you can drill down to any inside metric. You can compare yourself with some previous dates, so you can a complete control and good management of the life cycle of the quality. So the last one I want you to show you is the quality profiles, which is really the heart of all the rules. So you can have profiles for any different language. A quality profile is a set, a group of rules that a project is analyzed against these rules. The rules can be categorized by language, by specific repository. You can have several repositories in one language. Here you can see that you have findbugs, PMD, and some rules from SonarQube itself. Or you can use tags to group rules based on their characteristics. So for instance, we have some rules for unused code, or rules that are for Java 8. Right. And you can see also a very good explanation of the rule. And for most of the rules, you can a non-compliant example and a compliant solution. So developers can take a look at this code and educate themselves how they should write better and cleaner code. So I think we are done with a very quick introduction of the basic features of SonarQube. Let me go back to the slides and have a couple of things that I want to share with you. Let me share again. Can you see the slides right now?
No.
No slides? Okay, let me reshare the screen. I don't know why this is happening, but Okay. So, what's the big picture? We've seen a different picture of the kitchen before. So ideally, this is the kitchen I would like to have in my house, and ideally, this is the kitchen that I would like to see in my source code. So the big picture is that we want to track and reduce technical debt on an ongoing basis. That means that we need to clean up the kitchen every day, meaning that we have to clean up our code and maintain our code every day. And the next one is that not only uh, senior people or senior developers or technical leads are responsible for cleaning up the kitchen. All developers, from the newest one, from the most junior developer until the senior one, are responsible for cleaning up the kitchen. Just like the dishes are not cleaned only by our moms, but we the father and the kids should also clean up the kitchen. It's the same exactly with the source code. And the last one, the last slide I want to share with you before we have some time to answer any questions. Let me reshare the screen to give you the last slide. So this one, I hope that one day Luck is today the source code management tool. I mean, the first thing that a team actually installs and introduces when starting a project is the SCM, Git, SVN, or whatever. I hope that one day the second step, or even the first step, is going to be the installation of a nice quality management tool like SonarQube, and that all people are going to be from the first day on board with tracking and improving the code quality of their source code. So I think that's it for the presentation. I wish we had much more time. There are several things that you can discuss about SonarQube and several things that you can learn. I strongly advise you, if you haven't done it already, to download and start playing around, start analyzing any project that you have, personal or project for your companies, and see how the numbers are displayed. Try to understand what the numbers are telling you, and try to start working on it and to fix some issues and see how the numbers are getting better. And this is going to be a very good relief for you, and you can also discuss it with your team members, your colleagues, and try to understand what's the most worst number that you can start working on. So I think that's it. I can answer any questions that we have so far, or anything that it wasn't very clear for the during the presentation. I know we had some problems with this with the slides. So if you want something to be rediscussed, I'm here for you and to answer any questions you have.
Are there any questions? Edson, Paul, Jesus, Kathy? Okay, I think that there are no questions.
Okay, great. You can still.
I have a question here.
Okay.
Yep.
Yes.
Edu, can you hear me?
Yes.
Okay. Okay. What's the level of customization that we can reach with this tool as SonarQube?
Yeah, it is one of the highest advantages of SonarQube. You can customize everything, and I mean everything. You can customize not only the dashboards, what you are seeing. You can customize not only which files of the system you want to analyze, but you can also customize the quality rules that you're going to analyze your project against. Of course, SonarQube comes with a default quality rule, and that's a good start. You can start using SonarQube with the default rules, but my advice is that start to evaluate these rules and see if these rules are a good fit for your company for your team. So you can just modify their priorities or enable or disable rules that you are not making sense to you. So you can customize not almost everything in SonarQube.
Okay, and the second one is about the level of the capitation. In your experience, if in my company we will be glad if we could receive some capacitation, some learning about the SonarQube. How complicated is in your side to get this as a new technology to be used in a company?
Yeah, actually, the most important problem is not the technology itself. I mean, it's quite easy to start to install SonarQube and run analysis. I mean, it's really easy. You won't spend more than 20 minutes to install it and run a new analysis. The problem is that you have to convince your colleagues and your managers that code quality is directly connected with the quality that your end customers are getting from the product. So good quality means, of course, fewer bugs and makes the team more productive and can add new features more quickly. So this means that your customers are going to be more satisfied and more happy with you. So that's the one thing. The second one is that with SonarQube, every little problem in your code is going to be exposed, so all people are going to see the problems. So you might find resistance from some developers, especially some senior developers that are not used to this situation. So I think these are the most two important things and that you should have in your mind if you want to introduce SonarQube in a team.
Okay, and my third one and last question. And currently, I have the maintenance for a legacy system. So it's a large legacy online system, but the code is so unordered, and we had a lot of code duplications and a very complicated architecture, a lot of frameworks. Um, I don't know if you have been experience with those kind of software, and if it's possible, make an application of those integration tools with that kind of software.
Yes, of course. Yeah, actually, I was working in a company before some months ago that we have a huge legacy system. I mean, huge, to about 1 million lines of code. And of course, when I first analyzed the project and I saw the dashboard, was, oh my God, what I'm looking at. It was really awful. Okay. So my suggestion is that you can't start trying to fix every quality flows that exist in the legacy system. So I suggest that you start at least not making the code worse. So analyze the system, know what your starting point is, and then try at least not to make it even worse. If you have some time to spend and fix any issues of this legacy system, it's even better. But I know it's really hard. I mean, you're not going to refactor any code just for refactoring. But you can do the following approach. It is the Boy Scout approach, which is in the US. I mean, always leave the class better than before. So when you find the class, you are modifying a class to fix a bug or to add a new feature. Try not to focus only on your tasks, but improve the code that you found a little bit. So eventually, step by step, you will see that the quality of the code is going to be improved, and you're going to love it about that.
Okay, thanks for your answer.
Great, nice questions.
That is all for me.
Okay. So is there any other question? You can still reach me. I don't know if Edu has my Twitter and my LinkedIn account, so you can, and my email, so you can reach me if you want. If you have any other question by any of these ways, if you don't have any time to ask me now.
Hello, I have a question. Can you
Yep.
hear me?
Yes, I can hear you.
This is Edson. Well, sometimes I need apply some change, and I end with that code. But this code is only used in test, but not in another part of the program of the applications. SonarQube is excellent to say me if code not used in test. But sometimes I need know what code is used only in test to delete that code, because that code is not used in the applications really. It's only code coverage, but not used in another methods and another features.
So this code, let's say it is located under the source code directory, but it's only used by test cases. Is that correct?
Exactly. The code is used only in test.
Yeah, but where is it located? Is it located with the tests, or it is with the rest of the source code?
No,
I ask this because
code.
Sorry?
It's used only in test. It's production code, now it's dead code, but it is used only in test. So I need delete that code.
Yeah, no, I don't know any feature of or any rule that can find code that is only used in tests. Currently, you can find only unused code like private or protected methods or private fields, but SonarQube can find out right now if this code is only used by your tests. Unfortunately.
Maybe that's a great feature, great new feature about SonarQube.
Yeah, maybe. Yeah, I will send an email to the mailing list and discuss about that. Yes, I will. But why don't you just move this code that you have in the source code to the test code, to the test directory? Isn't that possible? Or you don't know yet which is this code?
I asked about, okay, an example. Maybe I have a sort method, but now I made a new implementation, maybe using new algorithm or new method, and the old method now is unused. But that method is tested, so it has coverage code. That code is used, and but I need delete the old code. In legacy systems.
Right.
I have code used in test, but a long time ago, nobody used that code.
Yes, I understand. Yes, no, you can't do that in SonarQube right now.
Okay, thank you.
Any other question? Okay. I think that there are no more questions, Patroklos.
Okay.
Thank you so much to share your knowledge and your experience with SonarQube.
Thanks a lot for the invitation. I'm going to upload the slides in SlideShare. You can view them whenever you want, and I will send you the link.
Okay, I will put in YouTube because this hangout is publishing there.
Yep. Okay, no problem. Okay, great. Okay, thanks a lot, guys.
Thanks so much, Patroklos.
Thank you. Thank you. Thank you.
Have a nice weekend.
Guys.
Okay,
Bye.
bye.
Thank you.
Bye.
Bye.